Well, long-term change in farming is often framed as a sequence of technological improvements, but scrutiny of each of these supposed step changes reveals them to be extended and variable in time and space, and not easily reducible to a novel technology. Let's take, for example, Marc Bloch's critique of the 18th century agricultural revolution, which focused on its institutional and political conditions. Bloch showed how intensive practices, things like manuring, weeding, enclosure, that were already widespread in gardens were scaled up for fields, eventually to overturn the low-input medieval open field system. He understood agrarian changes of the 18th century and the entrepreneurial individualism that drove them as essential precursors to the French Revolution. His attention to local sources and regional variability showed agricultural practice to be in a constant state of flux, the product of decisions by many individuals reacting to shifting circumstances. And finally, he pointed out that it is in the very nature of the agricultural reformers' stance to caricature previous practice as unchanging and backward, as was happening, he argues, in the 18th century. Well, given this critical distinction between the existence of a given farming technology and its actual impact in practice, as conditioned by institutional and political context, we should also be wary of any simple linkage between farming and inequality. Discussion of the origins of farming or of the original agricultural or Neolithic revolution makes farming sound like a simple on-off switch and a monolithic category, but farming is instead a wide spectrum of possibilities, even within a given technology. So one way to think about farming strategies is to consider how production could be increased. And let's leave aside for the moment the question of why we would seek to increase production, though I will come back to that, and what potential knock-on effects those strategies have or could have for wealth inequality. And I'm going to start with a Western Eurasian pre-industrial farming technology context, following on from what Sam has just presented, where we're thinking in terms of two major strategies, and I've called them here gardens and fields, Hackbau, Pflugbau. This is a classic distinction that I think will be familiar to all of you. Gardening involves high inputs of human labor per unit area, while field cultivation develops through expansion and the labor-saving combination of the plow with specialized draft animals. And just to conjure up what that might look like for you, these are examples of gardens on the left in northern Spain and on the right in North Africa, in southern Morocco, in an oasis. And I'm specifically showing you what is now quite an unusual thing to see, and you have to look quite hard for it, I know from my own experience, and that is finding cereals that are grown at a garden scale. In other words, crops that are now normally treated as expansive field crops. And we can contrast those with fields which are experiencing lower inputs per unit area, but may generate in aggregate much greater yields. So in a garden system, and this is a diagram with very small writing on it, produced by Sam, Mattia, and myself, the garden system is shown on the left, and practices such as manuring, so the addition of animal manure as a fertilizer, increase the value of labor, that is its marginal product in economic terms, and can be characterized as labor limited, or if you like, land abundant. Similarly, in a field system on the right, plowing with oxen increases the value of land and can be characterized as labor abundant or land limited. Well, given the differential susceptibility, as we've heard this morning, of labor and land to accumulation as heritable wealth, it's obvious that different kinds of farming could shape long-term wealth inequality in contrasting ways. But how do we diagnose these strategies archaeologically? And this is where I get nerdy, and I'm going to try and hold myself back from all of the gory detail. The preservation of agricultural landscapes, that is of actual fields, actual garden plots, is incredibly rare, though there are cases, and I'll show you some in due course. Instead, the most widespread direct evidence we have for farming is the preserved harvests of crops that are found on archaeological sites where people were storing that material. And this is the kind of stuff that you see on the right-hand side of the slide, carbonized or charred cereals. Those are cereal grains, as you may recognize. So it's that evidence that provides the basis for ecologically characterizing the conditions under which those cereals or other crops were grown, so that we can then infer how farming technologies were actually used to create those growing conditions and how they change under different circumstances. So I'm now going to take a strategic look at farming and inequality in Western Eurasia, and then I'm going to look at other world regions to try and build up a global perspective. So one thing we know now is that traction, that is the use of cattle, often cows in the early days, to pull heavy loads, is something that is already a fact from the very beginnings of farming in Western Asia. And it was probably a motivation for the early management of cattle along with milking. So these recent discoveries overturn older ideas of a secondary products revolution in the 4th millennium BC. That's one of the sequence of supposed revolutions that I showed you at the outset of this talk. Similarly, in Europe, we have evidence for very early use of the plow. This is from both cattle pathologies, that is, changes to cattle limb bones that are caused by pulling heavy loads, and also in the form of plow marks, and that's what you see in the upper left-hand corner of the slide here. I hope you can make out dark lines which are intersecting each other at more or less right angles. So that's an actual field, that's in the Netherlands, that has been covered by coastal cover sands. So in special preservation conditions, you can get actual preservation of fields, and you can pick up traces of the kinds of tools that were used to till them. But that's an exception. And in fact, the paper that I've drawn this from, which was published earlier this year, and I circulated it to some of you who were interested before this event today, is to do with very early plow marks now going back to the 5th millennium BC in western Switzerland near Sion, again under very unusual, quickly buried conditions where we then have that direct evidence of the plow, in this case the ard plow, the simple drawing of, as it were, a stick through the top 10 to 15 centimeters of soil and then cross-plowing to create a tilth. So any eventual or later shift from a labor to a land-limited system is not about technology per se, it's about how it was used and the context in which it was used. It's well documented ethnographically and historically that traction with cattle and other animals can form part of both garden and field-type systems. So it's not enough, in other words, archaeologically, for us to simply chart when and where traction is evidenced. We actually need to look instead at the impact that traction was having, what kind of growing conditions it was creating, and of course the institutional context. Well, I'm going to fast forward now to a particular, I think, game-changing development in Western Asia, and that is the emergence of cities. So much, much larger groups of people living together in dense agglomerations. And this is something that happens at different times and places all over the world. In Western Asia, and in this particular region, which I'm looking at here, northern Mesopotamia, which is a rain-fed zone, it begins in the late 5th and 4th millennium BC. So feeding these early cities, some of which are a kilometer square, 100 hectares or greater, such as Tel Brak in northeastern Syria, was a clear motivation for increasing production. And it involved making use of traction in a new way to prepare crop fields and to transport harvests over increasing distances from settlement. So farmers are actually living in these early cities and moving out to their fields at greater and greater distances. Radial field systems are visible in satellite imagery from the 1960s, such as the image that you see on the right-hand side here, which shows trackways, this is human and animal traffic, moving in and out of the urban core. The depopulation of these expanding arable zones, which is documented by archaeological survey around, in this case, Tel Brak, involved conflict and violence as apparent from the mass graves at Tel Brak and new iconographies of power. So I'm going to get a little bit nerdier still here, and this is something I'd be happy to explain further in discussion as needed. But I wanted to show you a real example of how we infer changes in crop growing conditions from the charred or carbonized remains of cereals. And the technique that is generating the graphs that you can see in this slide is stable isotope analysis of individual samples of cereal grain from a whole series of sites of different periods and critically different sizes in northern Mesopotamia. So the x-axis here is a logarithmic scale of settlement size as a proxy for population, and the y-axis is, and this is a little bit of a mouthful, the probability that there was no manuring. Manuring, the addition of animal manure to, or material to fertilize soil, affects the stable nitrogen isotope values of cereal grain. You're just going to have to take my word for that, but I'm happy to chat with you later to give you more information. And so what we find is that as settlements are expanding, including Tel Brak itself at different stages, we see a loss of manuring. So this means that low input, expansive field cultivation is kicking in. So the pre-existing technology that made this expansive shift from small-scale settlements intensively managing their gardens to cities expansively managing their fields was traction. And so, given the differential susceptibility, and so early cities were the context of a shift from labor to land-limited economies in northern Mesopotamia, its degree depending on the exact urban scale that was reached. And we can trace this process through the bottom-up dynamics of individual households, and some of those households are shown in the upper right-hand side. These are houses that are burned down with their crop stores intact. Well, we can observe shifts between labor and land-limited farming also in other parts of Western Asia, and often in conjunction with urbanization. Take, for example, central Anatolia and the site of Çatalhöyük, which Sam has already referred to. This is a site where a whole group of us have been working. It was a big international project, and even the archaeobotany team was quite big. And what we were doing was trying to characterize the nature of farming here and variability in crop growing conditions. And what you can see in these images is the very complex mosaic landscape surrounding the site, and in particular created by a broad braided channel belt. This is the Çarşamba River, which flows past Çatalhöyük, and created all kinds of different niches and opportunities for gradations of labor-limited farming. There are also a lot of sheep moving around this landscape and spreading their manure. And if we look at Çatalhöyük, the settlement itself, again, we have burned buildings, and the circumstances of their burning are politically interesting too. Sam has also alluded to that, in which we have different sets of crops that suggest different experimental approaches to farming and to subsistence. So we can contrast that set of circumstances at Çatalhöyük, which is back 7,000 to 6,000 BC, so that's kind of the later part of the Neolithic in archaeological terms, and we can fast forward within central Anatolia to see what's happening by the 2nd millennium BC. So this is by the later Bronze Age, where we find a dramatic contrast in farming under urbanization, and this is at the Hittite capital itself, which was founded in north-central part of the Anatolian plateau at Hattusha in the late 17th century BC. And one of the founding acts of the construction of Hattusha as this new capital was the construction of a subterranean granary that is what looks like a kind of multi-celled building that you see in the center of the slide here. So this is an underground building. This is hermetic storage of grain on a fantastic scale. The building is 120 meters long, 40 meters wide. At maximum capacity, it contained about 7,000 ton of cereals. That's enough to feed 30,000 people for a year. So this is what the Hittite state can mobilize. Interestingly, having mobilized these crops, it all went wrong. This structure burned down, preserving hundreds of tons of cereals, and I hate to think what happened to the people who were held responsible for that event. But in any case, this preservation gives us an unparalleled opportunity to characterize the farming system. And to make another long story short, the cereals that are being mobilized at this stage, which is the later part of the 16th century BC, are from emphatically expansive field agriculture, very different to the Neolithic gardening at Çatalhöyük. So, how do these long-term shifts from gardening to field agriculture relate to wealth inequality? Well, we've already talked a bit about house size and its distribution as a proxy for wealth and wealth disparity. We've also talked about uncertainty around those estimates, and I'll come back to that. I'm showing you here examples from central Anatolia where we have just been looking. That's Çatalhöyük again on the right-hand side. An earlier site, Aşıklıhöyük, is shown in the lower images, and the city that is shown in the upper part of the slide is early Bronze Age Kırıltepe. So also in Cappadocia, not far, in fact, from Aşıklıhöyük. So when we look then at the sizes of household units, we can also look specifically at their storage areas. In Mesopotamia and in Anatolia, the box plot on the far left of this slide, I hope that's legible, shows quite a marked offset between labor-limited and land-limited cases. There is some overlap in Mesopotamia, and you'll see overlap elsewhere too, but there is an emphatic difference in the disparity of house size under these different farming regimes. Equally, though, when we take governance into account, and we've used a method here developed by Gary Feynman and David Carballo, we find that governance moderates these differences, both for labor-limited and land-limited cases, and it brings them closer together. So that is just a brief snapshot of work on farming and inequality in conjunction in Western Asia. What about Europe? Well, as we've seen, there was certainly early use of the ard plow. The question is, what kind of farming was it serving? What kind of growing conditions was it creating? And I'm going to look briefly at a site that was occupied from the very earliest Neolithic in Europe. It's in fact some of the earliest farming anywhere in Europe, and that is at Knossos on Crete. So early traction evidence exists at Knossos, and this is the work of Valasia Izakidou, who has shown, and this was in fact doctoral work based at UCL, traction pathologies on cattle bones, which show a particular use of cows for plowing. And that plowing was likely concentrated in the valley of the river, the Kairos River, that flows past the present-day site as we see it, and would have been a focus for well-watered garden conditions in the Neolithic. So this is a case of cow traction actually serving labor-limited farming. I'm going to fast forward again to give you a contrast to that, to consider the growth of the city at Knossos, and this is an understanding of Knossos' early urban development that is thanks to the work of Todd Whitelaw, who's here at the Institute of Archaeology at UCL, through the CULP project, the Knossos Urban Landscape Project, which has shown how the footprint of the city changed over later prehistory. And my aim here is to suggest how farming is changing in tandem with that scalar change. So Knossos grew in the end to over 1 square kilometer. Again, we're hitting, interestingly, around 100 hectares. And we get the same pattern in terms of potential or probable manuring practice as inferred from stable nitrogen isotope analysis of cereal grain. I realize that's a bit of a mouthful methodologically, but what you're seeing for the Aegean patterns there is then very similar to what we already saw in northern Mesopotamia, which is that as settlements expand, they shift from a garden type of approach with lots of intensive manuring per unit area to a field approach with much lower inputs per unit area and where it's all about scale. Well, a key detail in the Knossos story comes from Linear B records, so an early form of written Greek, of the final palatial period, and that is that the palace itself was sponsoring extensive field cultivation by loaning out oxen in a sharecropping arrangement. And that's also familiar from early Mesopotamian records. So if we now want to make the connection to wealth inequality, and again, I'm showing you, as I'll explain a bit later, this is kind of hot off the press results of looking at lots and lots of house data, but now specifically Southeastern Europe. We again see, interestingly, higher wealth inequality with land-limited farming, but that is moderated by what we're calling here collective governance. And if, in case you were interested, some of the land-limited, collectively governed cases that we're looking at that I'm gesturing to with my cursor that you can't see, sorry, but it's in the lower right-hand part of the box plot on the right. So these are land-limited cases that nevertheless have quite a low set of Gini coefficients, are from classical Greece and from some of them, in fact, from Athens itself. Now, we've been looking so far at cases in Western Eurasia where we can play with this Hackbau, Flugbau contrast. But how do we distinguish labor and land-limited farming globally? What, in other words, does the labor to land-limited spectrum look like without the possibility of traction? Well, the garden end of the spectrum is similar regardless, whether or not traction is involved. It involves a lot of elbow grease and hard graft per unit area of garden plot. The difference emerges with land-limited farming and what that looks like. So without traction, it's possible to increase the supply of arable land through large-scale land desk investment, terracing, drainage, irrigation, and also by mobilizing abundant human labor. Labor may be accessible through nucleation in urban centers. It may be displaced or forced labor. It may be all-out slavery, where human labor itself becomes heritable material wealth in the very grim way that Sam has outlined. So in this kind of situation, the expected ecological contrast between labor and land-limited farming turns on the amount of labor invested and could result in dramatic land-esque reshaping of the agricultural landscape. So land limitations then can arise under vastly different farming ecologies and technologies. Well, an example of regional contrasts between labor and land-limited farming in the Western Hemisphere, so without traction, is provided by work of Pablo Cruz and colleagues in the southern Andes, and specifically in southwestern Bolivia and northwestern Argentina, and my next few slides are drawn from that work. So at the land-limited end of the spectrum, we have micro terraces built of field stones, which retain soil and moisture and are creating the growing conditions for quinoa and potatoes at high altitudes, so very cold, arid conditions, and archaeologically beautifully preserved. So this is an exception to the tendency I mentioned earlier that we very rarely find intact agricultural landscapes. If we shift southwards into northwestern Argentina and the region of Coctaca in the Inca period, we see a clear contrast and some of the most impressive pre-Hispanic agricultural landscapes preserved in the Andes. Here, a historically documented system of displaced and forced labor enabled a land-limited system to develop with elaborately built monumental terraces and impluvia to capture rainwater. again using housing disparity as a proxy for wealth inequality, and this is now across South America, so central and southern parts of the Andes. We see that land-limited inequality is indeed again greater than labor-limited, though it is again moderated by collective governance. Early Spanish colonization and the introduction of cattle led to a shift towards elongated fields suited to plowing and to a more European style of land-limited farming in northwestern Argentina, featuring also production of European cereals rotated with alfalfa. And I should mention, excuse me, before I go on, that in other areas, such as the Altiplano, the intersalar region of southwestern Bolivia, communities continued to practice labor-limited farming, so this traction shift didn't happen everywhere. And it's only in recent decades, since the 1980s in fact, and with new global demand for quinoa cultivation and the introduction of tractors, that the intersalar region, which had been for thousands of years very egalitarian and labor-limited in its farming approach, has seen a drastic increase in inequality driven by industrial land-limited farming. So, tackling this kind of issue on a global comparative scale needs not just one archaeologist, but many working together. So it requires wide archaeological collaboration, lots of different forms of regional expertise. And for the last few years, a group of us have come together, facilitated by the Coalition for Archaeological Synthesis, to bring together different forms of data, housing data sets, and associated expertise from around the world. And panning back now from some of the results these are unpublished results coming out of this project, to consider how labor and land-limited farming compare, and estimated here again on the basis of house sizes, we do see a significant contrast between labor and land-limited farming in all major world regions, as well as a good deal of overlap. And some of the uncertainties that Sam was emphasizing in his talk are taken into account in the curves that you see in the lower left-hand part of the slide. Now, I want to finish, and I'm not far off, Carl. I should have checked with you earlier how I was doing for time. I was enjoying myself. But I'm going to use my last few minutes to zoom in on some aspects of the results that are coming out of this project, which are opening new questions. So here's an example of one relationship we've been looking at, and that is the relationship between either house size, which is shown on the left, or site size, which is shown on the right, with the Gini coefficient, but keeping the labor and land-limited cases clearly coded so that we can pick out what they're doing. And what we see, perhaps not surprisingly, is that labor-limited societies or sites are those with relatively few and small houses. Land-limited sites tend to have more numerous and larger houses. So in some sense, that is actual gradations of labor limitation writ large. But we also see that there are different relationships, or in fact non-relationships, between scale and inequality. So whereas for labor-limited sites, there can even be a weak negative relationship between house size and settlement size and inequality, in the case of land-limited economies, there is indeed a positive and significant relationship. So increasing inequality with potential productivity, which we've touched on already, depends, we would argue, on the nature of the labor or land-limited economy. Another just snapshot of results, one of the final slides that I'll show, this is comparing labor and land-limited cases, again shown with different coding, different shading, in terms of the numbers of levels in settlement hierarchies from which these archaeological sites derive. So that's the number of levels on the left-hand side and the level at which each site sits, shown on the right-hand side. And in both cases, labor-limited sites tend to be those with few levels and sitting at low levels, whereas land-limited sites have more extended site hierarchies. So touching on the question of surplus, which Bob raised before and which Sam also discussed, it's not that there isn't surplus in all of these systems to keep site hierarchy settlement systems going. It's that those flows of surplus are much more extended in land-limited systems. And my next to last slide now, this is a hemispherical comparison of what happens over time in the Western and Eastern hemisphere. And rather than raw dates along the x-axis, we're showing you delta years. So this is the time since farming became locally common. And we can see that land-limited farming emerges. It takes time, though, to emerge. It's mostly after at least 2,000 years of farming being up and running. We also see that labor-limited systems can re-emerge much later. And I would note that the apparent increase of the Gini coefficients with delta time, that is with time elapsed since farming emergence, is not significant when you take the contrast between labor and land-limited into account. It's also interesting that we get somewhat different patterns in the Western and Eastern hemisphere. In the Western hemisphere, and this is statistically demonstrable, we have an inverted U-shaped trend, and in the Eastern hemisphere, a positive linear trend. And that is consistent. It could be consistent with multiple hypotheses, but one hypothesis we're exploring is that land-limited wealth inequality is less stable when it's dependent entirely on human labor